Hello and Namaste. In continuation with the rectification, the length of a plane curves, we are moving ahead with the polar form part 1. Now the length of an arc in a polar form is, for example, for the curve r equals to f of theta, we have the differential calculus. ds upon d theta is equals to square root of r square plus dr upon d theta the square. Now, if we wanted to find out the length of an arc of a curve r equals to f of theta between the points theta is equals to theta 1 and theta equals to theta 2 is given by s is equals to. Now let me show you this particular figure. So for example, this is the curve which we are taking care of, or we can say that this is nothing but r is equals to f of theta, which is moving from, or this particular curve is moving from this angle theta 1 till the angle theta 2. So this is the angle which is the dotted line. First dotted line is theta 1, another second dotted line is till the theta 2. It's given by s is equals to integration from theta 1 to theta 2 square root of r square plus dr upon d theta the square d theta. Similarly, the length of the arc of a curve theta equals to f of r between the points r is equals to r1 and r equals to r2 is given by s is equals to integration from r1 to r2 square root of 1 plus r square d theta upon dr the square dr. Now let us take an example and just understand. Find the length of the spiral r is equals to e to the power 2 theta from theta equals to 0 to theta equals to 2 pi. Now this is the equation of a spiral r equals to e to the power 2 theta. So differentiating r with respect to theta, we will be getting 2 into e to the power 2 theta. That means we need to find out the length of a spiral which is moving from theta from 0 to 2 pi. Therefore the length of a spiral, the formula as we have already discussed, this is the theta 1 and this is the theta 2 pi. So this is integration from 0 to 2 pi square root of r square plus dr upon d theta the square d theta. Just quickly putting the values of r square plus dr upon d theta the square. R square is nothing but e to the power 2 theta the square plus dr upon d theta the square, that is 2 into e to the power 2 theta the square, which is 4 e to the power 4 theta. Moving quickly with this, we will be getting the answer using the simple steps of integration. We'll be reaching towards square root of 5 by 2 e to the power 4 pi minus 1 as the answer for this particular length of the spiral. Moving ahead to the next, find the length of an arc of the equiangular spiral. R is equals to a into e to the power theta cot of alpha from the points corresponding to theta equals to 0 to the point corresponding to theta is equals to tan of alpha. Again the same. R is equals to a into e to the power theta cot of alpha is the equation of this particular spiral, equiangular spiral. So differentiating r with respect to theta, will be taking it out or getting it as a into cot of alpha into e to the power theta cot of alpha. Now again the theta varies from 0 to tan of alpha. This is what has been given to us in the question itself, and therefore just going quickly, length of the arc is nothing but from 0 to tan alpha square root of r square plus dr upon d theta the square d theta. Putting the values of r square and dr upon d theta from this first and the second. So we'll be getting this, making a move with the very simple integration part, and we'll be reaching towards the final answer as a into e minus 1 sec of alpha. Just go quickly and just pause the video, try to get the steps in your notebook so that you will be making a practice of this particular type of example simultaneously along with me just in this particular minutes. You can just check the minute of this, and this is all about the part 1. Stay connected, stay tuned for the upcoming sessions on the rectification. Thank you so much. Happy learning.